use a thumbstick to transfer G-code from the computer over to the Tormach. The cool thing about PathPilot is you can set it up with actually something like Dropbox with a Wi-Fi chip in the Tormach controller so that you don't have to deal with a thumbstick. But the thumbstick's really not a big deal. I like having the controller, especially when it used to be Mach 3, off the internet. And I'll share a little secret for anybody who's still watching. We're moving shops again. More to that, come to that later, but we found our new permanent home, I think. So once we get there, we might actually set up a network with the Dropbox stuff. So thumbstick goes in the computer, and all we need to do is do actions post, and I will betray a future video here, which is that the post I have set is for the plasma, which I'm trying to figure out how to get Fusion 360 to work with my plasma, because that would be amazing. And it supports it, but I've had a hiccup. So this is something I don't necessarily love, is it won't remember your post for a file. And that's an issue when I'm running a mill part and Jared may come in and use it for the lathe, and he has to remember to switch the post over. So we are using this PathPilot post here, and click post. I will choose the removable disk here, and I'll name it accuracy. Click save, and this little G-code editor pops up. I have no problems with this post. My preference, though, would be for it to list, where is it? Sometimes it's hidden behind this one. This post lists the tools in numerical order, and I would rather the tools be called out in the order they're called. That way I can sort of spot check and sanity check, because in this instance, tool 25 is the chamfer tool. That's the last tool that's used. But it's still good, and the really nice thing you can use is to check your Z minimum. So for instance, we know the Shearhog is going to go down, oh no, that's interesting, 0.9998. So why is it going that deep when in theory we're only cutting down half this part? Well, remember, we're going all the way through in the middle of the part. So I don't usually honestly spot check this G-code. We're good to go. So just close this, pull the thumbstick out. I'll see you over at the machine. Thumbstick. I use a USB extension cord, which lets me put my thumbstick in right there. Touchscreen is a must-have. File, USB, accuracy, copy, load G-code. Great. Take my Heimer. This is one of the things I got to fix on the maintenance, is the spindle has some dings in it, and that's been making my tools pull in and out very difficult, and that is the biggest reason why I have not been using the tool changer as much, and that is completely my fault, folks. I will not, I don't want to have any misconceptions about that. So come down now on Z0, again, touchscreen makes it super easy. That's Z0. We're going to go about 10 thou past that, and that's going to do two things. That's going to solve the problem that, remember, the facing op in theory was happening at Z0, so it needs to be below, oh, whoops, that's embarrassing. There's a good lesson for you on camera. As a general rule of thumb, I never use my hammer while my Heimer is in the machine, because you don't. See what I'm talking about? That's what I got to fix. Not a big deal to fix. We'll do that in the maintenance video, but okay. So parallels in my soft jaws, or jaws, put the part in, hold, push down, tighten the vise. Now I tighten it pretty firm, and then don't laugh, lots of people hammer incorrectly. Dead blow hammer, one hit, hold the hammer back here and let it smack. Don't death grip it, let it do the work. That's it. Parallels, perfectly tight. Awesome. Now you can resume being a real machinist and not an idiot who starts a video tutorial without the part tightened down in the vise. Okay, tool 99. Okay, so again, we're going to go set, So that's 0. What we're going to do is set Z to 0.01. So that's saying the current plane, which is the top of the physical part, is 10 thou above what I want to cut as my face plane. Go back to continuous, find our back edge. This is why, to me, the touchscreen, so yeah, hold on. So I got to go down to tenths to come in real accurate. Okay, that's Y0. The touchscreen and the Heimer are a deadly combination. It's also one reason why I don't understand why people think that stupid jog shuttle wheel is faster. I don't believe it's faster. Now, do my sanity check. That's the left side of the part. Well, we're dragging across the center. Right side of the part looks good. The other thing you can do, and that's really nice about that Z-min, is you can make sure, okay, we're cutting down on the outside, that was lucky, to about 0.5, but if you see the Z here is 0.65, so we've got about 0.15 inches of clearance above the jaw, plenty of room. I'm not even going to stop recording. Let's just go. Throw my eyes on. My coolant lines, I usually just do a check. I usually don't leave the vise handle in, and don't ever touch your coolant lines when your Superfly is, well, frankly, period, but especially when your coolant lines are in there. Actually, you know what? I am going to adjust this camera. 1 second. All right, Superfly. I am leaving the enclosure doors open for the purposes of making a video. That is going to be a big mistake with the Shearhog here in a minute. Won't be as big a deal on the Superfly. Again, 2,500 RPMs, 15 inches a minute, spectacular finish. We cover the whole part in one pass. You can probably see that we're still cutting a hair on the back side, and that has to do with the tram of the machine, and that's something that we're going to tackle as well in the maintenance video. And I'm really not joking about this Shearhog. I might have to leave the room and let the cameras roll because these things are beasts. Okay, great finish. I mean, you can see my hand and the fingers and the reflection of that part. And again, that's with frankly a shitty tram on the machine. Coolant is not actually as big a deal with the Shearhog because you've got the insert geometry means you're not even going to hear me talk here in a second. Here we go. Too much. I got to reduce that tool path a little. Be right back. Okay, I reduced it to a 0.3 step over and 45, I think, inches a minute. I honestly think that should be fine. USB, takes a second to show up sometimes. Copy, overwrite, reload. Okay, we're good. I suppressed the first facing up, so you can see tool 49 is the first one. Page up. I actually want to make sure my G30 is high enough. I was using a low one earlier. So that sets the tool change, or sort of the tool change height. Go back to main, and now we'll try it. I should do another video on really pushing this Shearhog to the limit, because it's a question of how you use the torque curve on the machine, and obviously that recipe of step over, step down, inches per minute, so forth. Because I don't think, from a horsepower standpoint, we're not even at 1.2. This is fine. what I was trying to say is you don't necessarily need a lot of coolant because there's so much open area. You're not going to have any chip loading issues in this tool, which is great. And so the coolant here, it's not a bad idea at all, but it's really, again, not as important as you might think. Ow. Look at that chip, folks. Can you see that? I mean, freaking awesome. I don't know if this is going to be in focus on the GoPro. It was hot as could be. I mean, that is a awesome chip. Okay, now, some little cleanup things here. I'm really curious to see how the ramping goes. It might crap out on us because plunging in takes a lot of power. We're only at 27 inches a minute. Oh man, that sounds phenomenal. There's no noise at all. Listen to that. Oh, I love this. Look at that, folks. That's awesome. So normally, a lot of times I would use my 1/2-inch drill number 9 to drill a pilot hole and then plunge straight down. Look at this. This is beautiful. We could definitely go faster. I meant to look, what was our feed rate a minute ago when we were actually running the roughing, hogging out of the part. This is awesome though. God, that Shearhog does a great job. 45 it looks like. Yeah, so 45 inches a minute, 4,000 RPMs, 0.3 step over, 0.25 down. I'll look up, I think that's like a 1.6 cubic inch a minute. Not as good as we got with the 1-inch Shearhog. I think am I misremembering? I think we were at 6 in that video. More to come on it. Super happy. Okay, so the other thing is that because we took 10 thou off the top, I'm thinking, unless I mismeasured the extrusion, that this should actually poke through. It did not. Very close. Yeah, very close, as you can hear from that horrendous sound. Oh, there it goes, yeah. Perfect. Okay, tool 32, and it's important, you want to poke through that because when we're running this tool 32, you want the chips to get out of there as easily and as quickly as humanly possible, because there's just no way around it. A single chip being recut impacts your chip load, it impacts your deflection, your surface finish, your accuracy, it just does. Cool thing in Path Pilot, we can mess with the GUI. Couldn't do that in Mach 3. So you can see, I think this is going to finish up this horizontal op, and then we've got to do the 2 accuracy 2D pockets, and then here we go. And then the chamfer on the top there. Now in theory, maybe I goofed. I was supposed to have that run at .499, the thou above. I wonder why it's not. Well, we'll see. Oh, here it is. Sorry. Okay, that was still the last horizontal piece right there. Yeah, so you can see this is going to go down to 499. Perfect. Okay, so this is the spring pass. There's something coming off there. And you know, that's the funny thing. Every tool deflects. People think, oh, it was a big carbide tool with a thin cut in aluminum. Every tool deflects. Just a question of how much, and is it even measurable? Now this is going to have more of a cut because the horizontal didn't come into this pocket to take some last cleanup. That's all the better that we have a spring pass. So there's the spring pass. That's definitely taken some cut. This is that Lakeshore Carbide 5/16 3 flute. I love the tool. It does great. Okay, tool 25 for our chamfer. Surface finish looks good. I'm very excited to measure these and see how they do. Cool, right? You can kind of zoom in, look around. The ISO view, I never do that, but it's actually really helpful to get an idea for what's going on in the G code. Seriously, what else can you do? Front view, I guess that's good for your depths. Can you not scroll? I guess you can't rotate around or jog around, huh? That's okay. Looks good. So in production, I would want to change the Z-plane, safe plane, so that it doesn't go in. It's going plunging at 3 inches a minute all the way from the top of the stock. No big deal here. That looks nice. All right, we're done. Nothing else to do. You know, I do blow the parts off, but I'm trying to get away from using too much compressed air because it gets in your vise and your ways and your machine. So let's go back to the desk and measure this thing up. Okay, folks, first of all, I think this looks great. Now, we're talking about a machine, again, I bought 5 years ago, and I have spent almost no time maintaining. I know that's embarrassing, but it's just true. I really haven't, and it needs, we're going to replace the spindle. It needs some work there. It needs trammed in. The backlash probably needs adjusted, but that finish on the horizontal op is great. The Superfly is great. The sidewalls here are great. They're just great. And again, you know, I've heard from some folks lately that Tormachs just aren't up for the task, and it gets me a little frustrated because, darn it, sometimes it's the carpenter, not the tools, and again, it's not fair to compare them to a machine that starts at 4 times the price. Anyways, enough with that. These are not the way to measure anything, frankly, but just make sure we're in the right ballpark. Okay, that comes out to 1 point, you see that? 1 point. Actually, really? I mean, that's coming out to a half over. I don't trust it. That's coming to a half under. This is really not the way to do it here at all. That, what, are you kidding me? That looks like it's a thou under. I've got my grandfather's old Miller Falls micrometer set. I really don't use mics a ton. Some on the lathe work, but I'm just being honest. It's just not something we do a lot. So we've got a 2-inch bar in here, 2-inch test gauge. Just make sure we're kind of on the right page. If we come in here and we try to do this. So I'm showing, these don't have a vernier on them, but I'm showing there maybe half a thou or, you know, 2 or 3/10 over. So they're not perfect. That looks pretty close. But again, I'm more curious with this Tormach to see, are we, you know, 2 thou off or 3 thou off or whatever. So come in here. My lack of big micrometer use is evident in my amateur way of holding and using them. So, oh well. Okay, so let's see here. Coming in. Let me zoom in on the camera here 1 second. So that's 5 thou over. Okay, so that's showing me we are thou and a half under. Same thing, maybe a hair more. Let's try it this way. Ooh, that's not even, that's you know, 7/10 or so. Now again, maybe I got to go calibrate these better because I really want to know. Thou under. Okay, let me grab my snap rings here. Now the way you use these is tighten them in, let them snap out, put them at an angle. Now you tighten them, and then as you rotate them through, it'll force them in, and as soon as you cross center, you tighten them in and you relax back out. Put our part aside. Oh shit, that's spot on. Well, sorry, that's a thou over. Half a thou over. Folks, this is no complaints about this. Which angle did I just do? Right. Yeah, basically the same thing. About half a thou over. Sweet. So that's a wrap for today, folks. I'm actually pretty tickled with that. I know my Tormach's got some backlash. I know it needs some tweaking and some love. We're excited to do it. I'm glad that we have sort of a control. We'll run this part again. We'll see how it looks, finishes. But look, one of my things as a business guy is send out parts that you're proud of. And one of the reasons I did this project today was last week we had to do a show part for a customer that was a display part, and they really wanted it to look good. And I was nervous because I didn't want to meet expectations or not meet expectations, and we nailed it. Well, they haven't told us, but I felt damn proud of that part. And you know, I know this has got some toolpaths shown here, but that's really flat, folks. That would come out very easily with certain post processes. This would end up anodizing beautifully. The customer would be happy when they open this up. They look at that and they think that was done well, and that means a lot. So that's a wrap, folks. Stay tuned. I'm so excited. The 440 is coming. Then we get to do the maintenance video. The Carl Lakeshore Carbide tooling videos, half of them are up, but we're just tweaking them a little. So lots of good things to come, folks. Take care. See you soon.